Hello class, I hope you are fine and I'm also fine. Hopefully you have been going through this handout which I gave you, which was dealing with the concept of the Newton's laws of motion. And I think you are now familiar with the Newton's first law of motion, which is the law of inertia, and then the Newton's second law of motion, which is to do with the rate of change of momentum with time, and also going to the third law of motion, which is about action and reaction forces. So I want to share with you or even discuss with you a few questions here and there, some of which you have posted in the group for our discussion, so that we may revise that topic online. So I hope you have really gone through some of the examples. They are not so difficult, so that we can go maybe into the past paper questions for our discussion. But briefly, I want to discuss with you the concept of conservation of linear momentum, which is in the concept of collision of bodies. That when bodies collide, they may collide in such a way that they may stick together and continue with a common velocity. That kind of collision is called plastic collision. Plastic collision. The plastic collision is such that if a body, going to represent the body using a circle, is traveling in the same direction at a certain velocity, maybe velocity 1, and another body is stationary or even moving at velocity 2, some distance away, both of them moving in the same direction. Now before collision, this could be the situation before collision. Now the plastic collision is such that when the two bodies collide, they will stick together and then travel at a common velocity. These are just the representative diagrams. These are not balls, they are just representing bodies. They could be trolleys, they could be some trucks, even vehicles, such that when they collide, they don't separate, they move as a single entity with a common velocity v. Common velocity in the same direction, of course. Now, during plastic collision, momentum is conserved. Momentum is conserved. But kinetic energy is not conserved. What that means, not conserved, is that some form of energy is lost. Okay, beginning with momentum, that means momentum before collision equal to momentum after collision. That's the total momentum before collision equal to the total momentum even after collision. That is what it means, momentum is conserved. Now, kinetic energy is not conserved because we know by the principle of conservation of energy that energy cannot be created nor destroyed, but it can be converted from one form to another. So during this type of collision, the plastic collision, there is some energy lost in the form of deformation, because the bodies undergo some permanent deformation. They undergo some permanent deformation. Permanent deformation occurs. So the objects stick together and they lose their shape. So that mechanical deformation, talking of mechanical deformation, we resort to some energy being expended or dissipated or lost in some way. Also, sound may be produced during the bang or during that collision, sound energy. Sometimes heat energy. So meaning that the total kinetic energy is lost, so that initial kinetic energy, or say final, let's say final kinetic energy is less than the initial kinetic energy. That is, after collision, the final kinetic energy is less than the initial kinetic energy, that which was there before collision. So that is one characteristic. I mean, that is the major. I mean, that's how you can define, or that is the characteristic of this type of collision, which is plastic collision. Now, on the contrary, there is the other type of collision, which is elastic collision. This type of collision is whereby if two bodies were moving, say, in the same direction or even in opposite directions, as demonstrating the same way, you have body A and body B. If they collide, then there is a certain separation after collision. Momentarily there is some separation, bouncing off from one another. So that bouncing off brings about the separation, momentary separation at impact. So the bodies will temporarily separate. Actually, they will separate in opposite directions, and then they start moving. So elastic collision is a type of collision whereby both momentum and kinetic energy are conserved. So that is the main difference between the two types of collisions. In one type of collision, the plastic, which resorts to deformation and sticking together, moving at common velocity, there is only conservation of momentum. But in the elastic type of collision, both momentum and kinetic energy are conserved. Meaning, momentum P before equal to momentum P after. So, okay, moving on, we are saying that the momentum, of course, we are using letter P here to represent momentum. There's a symbol, is a notation representing momentum. So momentum before collision is usually the same, is equal to total momentum after collision. Also, kinetic energy before collision total. So if we use this symbol called sigma, total kinetic energy before collision equal to the total kinetic energy after collision. That is why this type of collision is said to be conservative. It conserves both momentum and kinetic energy. So examples of such collisions or systems, examples that are approximate examples of elastic collisions the bouncing of the basketball. Bouncing of basketball. Almost an approximation, because you see, when the basketball is bouncing from a certain height to the ground, it will not return to the same position because some energy is lost. So it will bounce maybe through that height, then height 2, height 3, height 4. Finally, it will stop from bouncing. So the bouncing will be back to a reduced height until it finally stops, because energy is being lost, the kinetic energy is being lost. Even at the impact, when it impacts the ground, there's some slight deformation, and then they recover their original shape and size. So elastic collision is about the characteristic of that collision is that there's a slight deformation, which is slight and temporary deformation on impact. So during collision, that is a slight deformation takes place, which is temporary, and then the bodies regain their original shapes. And during that elasticity, the elastic aspect is the one that conserves the kinetic energy. So to say some approximations of scenarios in our daily lives, we have the bouncing of the basketball. Not 100%, of course, some energy is lost. Also the snooker game, the pool table. You know this pool table where you knock balls against each other, the knocking of balls. etc. So some of the examples of elastic collisions in which both momentum and kinetic energy is lost. So hopefully I've been able to explain the difference or the main characteristic differences between plastic collision and elastic collision. So when we are dealing now with questions, we shall be using those facts of conservation of momentum and also conservation of the kinetic energy. Thank you.